Thank you. Thank you, everybody, for taking your time for being here today. And I hope you're still fresh enough to follow this talk. It's quite dense, and I hope you like code. Otherwise, it's going to be a quite annoying talk. I have to ask you one favor. It's going to be really dense, the talk. So I encourage you, if you want to completely understand and follow what I'm saying, to not use your notebook and just follow the presentation, because there will be a lot of code. So if you just listen to me and you don't look at the code, chances are you will end up getting out from the door and say, like, what did he talk about? Okay, so quick introduction. I work for D&Simple. We provide domain management services for a bunch of people. We provide domain registration, necessary certificates, automation via API. These are a few of our customers. We provide, for example, services for Ruby gems. So if you ever installed a gem before, you actually used our service. And I think you installed a gem before. So why am I here at a Ruby conference talking about different languages? So this chart here somehow summarizes my relationship with programming languages. In the last 10 years, I've been writing production code with more than 15 different programming languages. I love programming languages. And I've been mentioning over and over in my presentation in the last years about the importance of being influenced by other programming languages. I mentioned that this is a slide from some of my talks that I presented at Tropical Ruby in 2015, RubyConf Philippines, RaceConf. And this is actually a real slide where I was encouraging cross-pollination from different languages. And today I want to try to explain why I am encouraging that. And so I made an entire talk, I made an entire presentation about this specific idea that I have. And so to me, learning a new programming language is like starting a new journey. So when you pack for the trip, you don't know what you can expect, right? So you don't know what you will see. You don't know which problems you will encounter. But no matter what, when you will be back, you will have grown as a person. Whether you will be better or worse, that's a completely different topic, but you will have changed your way of thinking about different subjects. And in fact, to me, traveling is, beyond being one of the most funny and interesting experience, is also one of the most effective ways to improve myself, being in contact with different cultures and trying new experiences. So let me show you a few of them. I don't know how many of you actually knew that pineapples were growing in bushes. I thought they were growing on trees. Now, how that made me better as a person, I have no idea, but it's actually something that I learned. And this is another experience, like mind-blowing experience that I tried while traveling and living in Indonesia. This is me in Bali, trying to stop by a gasoline station. So they have no gasoline station. It turns out that there are groceries selling gasoline within vodka bottles. So you can see here, those are all vodka bottles filled with gasoline. And it seems like cider. You know, you're stopping there, you want to drink a cider, but it's actually gasoline. And the way they refill your motorbike is by pouring the gasoline into the motorbike with the bottle. You know, again, how do you use that? I would say probably survival skills, but it's just something that changed my perspective. Today, I want to show this different type of influencers, right? So I want to show you something that you can reuse in your daily job. And to me, influencers can be either traditional languages. You all know about C, C++, C#, Java, and Ruby, and so on. But there's also a bunch of emerging languages. Now, it's important to note that emerging, to me, is not necessarily a new language. We have Erlang and Haskell that has been around for years, although they have been emerging lately because, as you have seen in other presentations, we changed the way computers are improving, evolving, and so some programming languages that were not really right to be used perhaps like 20 years ago, they are perfect these years because of the way our computer world changed. And then we also have bridges. I mean, JRuby is one of the most notable examples in our community. Ruby running under the virtual machine of Java, right? This is an amazing influence taken from a different language. And then we have Helix, which is Rust and Ruby together. And then we have Erlang running under the Java virtual machine. You may be wondering why. I'd say, why not? I mean, it's an experience, and pretty much like you would experience with pineapples. It's interesting to see how new languages are coming and going away, and I don't expect you to see the code here, but I wanted you to take note of this website that fetches information from GitHub to show how code adoption, like different programming languages are changing today, looking at code contribution in GitHub. I want to quickly go through some programming language paradigms. As you probably know, we have object-oriented programming when we essentially talk with objects. So our model is designed around the idea of objects. Then we have functional languages, and we had a couple of presentations that mentioned to functional languages today. One of the key elements of functional languages is immutability, and we'll talk about that later. And then we have procedural languages, which is essentially you have a series of well-structured procedures and steps. And this is pretty much like you would expect to read some code. You know, like starting from the top to the bottom, you just go through whatever it has to do, and you perform changes on the data that you have. Now, what personally influenced my way of working are those languages. So specifically Elixir, Go, and Java, and I will show some code today. And also, well, Ruby, of course, influenced the way I write other Ruby code or other programming language. And Crystal and, yes, Prolog. I wrote Prolog code. How influenced that? Okay. Today I want to focus on 3 different languages, okay? So we quickly introduce you to three different languages that changed my mind, and I feel that can be interesting for you as a Rubyist. The first one is, of course, Go. Now, Go focuses on simplicity and readability. Has an amazing concurrency pattern design architecture. It's designed and focused on composition, so like composition of element. Has an amazing set of tooling and a great ecosystem. It was designed and invented by Google. Has an amazing fast build, which means it's a compiled language, but it's extremely fast to compile. It's excellent for network libraries and has an amazingly high quality standard library. This is some of like Go example, Go code. I added some code here. I don't expect you to read that. That will be available for whoever is going to download the slides later. You can check into that. Now, why it's Go interesting for the Rubyist is because it's an excellent replacement for some network operation or background task jobs. Has an incredibly attention to details and expressiveness, much more than what you could expect from this kind of language. Has real concurrency, it's excellent at manipulating data, and has a good solution for small web services. The other thing is that Go completely changed my perception of how I write code and the perception of quality. Now, it's really spread across the Ruby world to think about a 30 lines method is a bad code. Right? Whereas you can totally find 30 or 40 lines of method in the Ruby standard, in the Go standard library, which is extremely well designed, right? So that's actually a mind shifting to me. And I will talk a little bit more with real examples later. Then we have Elixir. I think that a lot of you knows about Elixir. It's a programming language that sits on the Erlang virtual machine. Again, really well designed for concurrency. Has an amazing feature called pattern matching. Again, it's immutable, excellent tooling. You can think about pretty much drop-in replacement for Rake or other tools. It works really well with Erlang. It's extremely good for binary manipulation. Example of Ruby code or Elixir code, and why I feel that it can be interesting for you as a Rubyist. Well, the syntax is really close to Ruby. Has a framework, web framework, which is called Phoenix, that has a lot of similarities to Rails in some ways. IX and Mix that are essentially the alternatives to ERB, IRB, and Rake. The community is composed by a lot of ex-Ruby developers and has a short learning curve, especially if you're coming from Ruby. And another language is Crystal. Crystal is essentially almost a drop-in replacement, like compiled replacement for Ruby. It's an amazing language. It's really fast. It's type inferenced and has direct binding with C and has compile time evaluation and generation of code. This is an example of some Crystal code. Seems like pretty much Ruby code. Now, why Crystal is interesting for Rubyist? Well, first of all, the syntax is really close to Ruby, so short adoption. Ruby style, but type inference, that can be really useful when you have a large project. And immediate productivity. You can pretty much switch to Crystal really easily. And in fact, Mike made an attempt to port Sidekick to Crystal, and it was done in a very, very short amount of time. Now, what I want to show you today, and right now, this is the heart of my presentation. We haven't seen any code so far, is how those languages changed my way of writing Ruby code. First of all, what I call structs to the rescue. Now, let's take a look at this class, right? We have a very simple class. We have a refresh method that fetches some information from the outside and changes the state of the contact object. Now, I've seen this approach pretty much everywhere. The problem with this approach is that it's extremely hard to test because you have to set up an object and perhaps make some mock about external dependencies. Now, let's take a look at this code, which is actually even worse. This code is a combination of state changes and static methods, class methods. So we have, for example, find and renew that perform operation on a domain, and they are not mutating any state. They are just changing information to the outside and returning a domain object. And then we have refresh inside this context that changes the state of the object itself. Let's focus a little bit here. Class methods, not changing any state, returning any object. Then we have change of the state, and we have initialize that return an instance of the same class where all these kind of logic is structured together. Even worse use case, in this case we have renew, which is not even a static function, is actually a class, an instance method. So we have part of the code, which is instance methods, and part of the code, which are static methods. There's apparent no logic in the design of this class, and this is actually real code that we had in the past. The problem with that is, in order to use the renew, you actually have to construct an instance. So in this specific case, we have to perform two different calls to the external service to make a change, because we didn't have any other way to construct the object to call the renew method on the specific object. What we can do to improve that is to use a different approach where every class method that encodes operation doesn't require instances unless has to deal with an instance, like in the specific example. But there's also another improvement that we can make. Did we actually forgot that Ruby has struct object? Now, this is an influence that is really, really common in languages like Go, for example, where structs are used pretty much everywhere to pass around the data. I'm not talking about the specific struct class that we have in Ruby. I'm actually talking about the concept of the struct as a container for data and nothing else. Just data container to pass along information. This is an example in Go. In Go, we use struct to represent a lot of different elements. We use struct to pass data around. We use struct to define types. Here, for example, the domain is a different type. The domain service is a kind of container for operation on that specific domain field. And then we have data, like the domain response and the domain list option, which is a configuration object. So let's have a look at how we can change this code to refactor that into using structs. So let's have a look at how it's embedded the definition of new here to the same class. We can create a new struct object that has nothing else than methods to deal with data and refactor the code, the registrar code domain, to return new struct objects instead of having an instance of itself being returned. What's the advantage of that is that here it's a very simple example, but in a very large example, you can actually get these kind of improvements. A class that was a really huge mess because we have a combination of data manipulation and operation can suddenly improve to an A because there's a separation of concern. And even testing is much, much easier. So today, most of my code, especially for dealing with third-party services, is designed to have data and operation. We have struct-like object for that primarily exists for representing and passing data around. And instead of using hashes, which is actually another problem. And we don't mix heavily data-oriented object with operation. The advantage is we have separation of concern and we have no state changes because the data is almost immutable. We can pass around the struct object without have to change in the data. Every time we have a method that changes the data returns a new struct object. And this leads us to a new possible improvement, which is taking into Ruby world the idea of stateless business logic, which is really, really close to the idea of functional languages. In functional languages, we have very little side effect because we have no mutation. We have immutable data. And we can reuse this approach in our code. Like imagine a method that every time you call it, no matter what, will always return exactly the same result. I don't know how many of you had the issue of passing a hash as option to a specific method and having the method that some way was making manipulation, like taking out an argument and then the hash was changed to the outside world. Okay? That's really, really hard to debug. So let's have a look at this example. This example here defines an order processing class. Let's focus a little bit on a particular piece of code, the account model. And we have a score method that is going to take some information from an outside service. Now, it's really bad to have external services connection within your model because you will mix persistence with integration to third-party services. So what we can do is that we can extract this code that are the details, specifically the call to the external service and the change of the persistent information. First of all, introducing a API, a custom API. So we have a specific, concise method that defines the action that we want to perform on the persistent, on the data. And then the next step is to have a different object, which we call service objects, that deal with, again, business logic, the operation that has to perform around that specific data. In this case, I introduced the method. The method is empty because during a refactoring, I don't want to make too many changes. It's empty, but it's injected as a dependency in the original method. Next step is to move the body of the method inside the service that I made. And after that, I can update the original order to replace, as you can see here, to replace the direct call to account.score to the service that I created. Okay? And I have separated the operation from the persistency, from the data. Let's have a look at new changes that we can make. Look at, again, we have a lot of business logic inside the order that deals with a variety of different tasks. Computing the total, charging the account, so contacting our payment processor, and notifying the account and changing the state of the order itself. So we can do what we did with the account. We can introduce an order service, and the order service will process the order, will deal with the processing of the order, will deal with the business logic of the order itself. Next step, let's move the body of the processing inside the order service. And here we go. Our order model is now just dealing with the data around the order itself. Much more easy to test because when we have to test the process order, we can just pass a simple object as an order instead of having to pass a full order with items and so construct an environment just for a simple test. And we can process over and over. We can introduce the dependency injection that I will talk a little bit later and move the account service into the initialization so that we can inject other service dependencies at runtime during the test. We don't really care when we test the order service to go through the full testing of how the account service works and everything else. We can simply pass an object, a double, a mock, whatever you prefer, that pretends to be an account service, and we are fine with that. We have to focus only on the order service itself. Next step, we can refactor more operation into services. We can introduce other services to deal with different topics. So for example, we can introduce the payment service to deal with only payment. And we can test the payment service on its own. The payment service will be tested going through the whole operation of the billing processing, contacting the payment gateway, and all those kind of things. Otherwise, what we have to do is that when we deal with the order processing, we have to mock the dependency of the payment processor, which has nothing to do with the order itself. It's part of the billing. It's part of charging the order. So in this way, we can simply pass, when we construct the test, when we construct the service, we pass a simple object that exposes the charge account. We can simply return nil. And we don't care about mocking and stubbing full stack of connections to our payment processor. Next step, we have to replace the original call to our main order process method. How do we do that? Pretty simple. We swap the call to the instance method on the model to invoke, to pass by the processor inside our order service like we had. And we provide the order, the data. Look at how we pass around the data as a parameter. Now, bear with me with the change. Sorry, I was actually looking at another slide. Yeah, okay. And this is our final example. That's how our models look like now. Whenever we have to test the model, we can test them in isolation without having to mock any dependency to third-party services. So those tests will be extremely fast and will be extremely efficient. And the API is nice and clean. And that's how the business logic is described. We have services describing the business logic for all our objects. And if you're asking yourself, like, isn't that writing much more code? Yes, it is. But writing more code is not a bad thing. You are a developer, so you should not be afraid of writing code. Otherwise, you probably choose the wrong job. And we can see this example pretty much anywhere in other languages. This is an example in Go, where, this is actually an example in Elixir, sorry. Where we have to pass the dependencies anywhere as part of the method arguments, because we have no state changes. So for example, look at here, in this specific method, we have to pass the accumulator that will be used in other programming languages, will be passed as an instance variable. We have to pass it as an argument and be explicit about that, because we have no other way to access it. So how my code changed today? Today, I use a lot of function-oriented service objects to describe and outline business logic. And then the model represents the data to be manipulated, and they expose custom functions. That's the other thing. I don't call .save, .update, or whatever other base methods inside the model, outside the model itself. I expose custom API that are well-designed, well-tested, and I am in control of them. That would reduce side effect caused by states, simplify test by reducing setup of unnecessary context, slim down model objects by removing third-party interaction, for example, with third-party services, and expose the business logic in one single place. You want to see all the operation that you can perform on the order, bam, they are there in a single class. Are you still with me? Yeah. I need to take a break. Wow. Okay. Next step, let's try to be a little bit more functional. Wow, and survive, first of all. Let's try to be a little bit more functional in our code. Now, why do we want to do that? We have seen that functional code is less prone to side effects, which essentially means we can clearly see what's going to happen. We have pretty much all the code in front of us. We have all the ingredients that are contributing to the final recipe. So if something is wrong, we know what we pass, and we know why it's wrong, at least most of the time. So I've been adopting a much more functional style in some of the code that I have been writing in Ruby. And I want to show you a really simple example. Let's go back to our orders controller where we have the order.process. And as you recall, we changed that to use a service. And bear with me right now. I'm just making a quick switch and use the registry pattern here. I'm not going to go through that, otherwise it's going to take years. But bear with me with that. So it's going to be essentially the same. We have a registry where we have a single instance of all our services in a centralized place. And nothing changed. We still call the process order. Now, what I want to have you to look at is how we call and receive the result of the processing. So we call process order passing an instance, and we reassign the result to a new instance, to the same variable. You may be wondering why. We could have changed the state of the instance inside the process order. Nothing was forbidding us to do that in Ruby. But let's try to have a look at how we will have to test that specific code, changing the state inside the method. First of all, we will have to create the service and then call the service. But the real question is, how can we set expectation on the returning object that was processed? In other words, that service was creating a new instance, and we expect the new instance to have an ID. And the ID was not there before. So how do we change the state of that object in our test so that we can use the updated changed object in our test to set up expectation? Because our view may need to perform, to check expectation in that specific result. For example, to redirect. So what we can do is that we can set up a stubs created order. We set the created order as a return value of our expectation. And now we can write, for example, I expect the controller to redirect to a specific URL where I can set the order ID of the object. And I can only do that because in my controller I was reassigning the value. So what I'm doing here, essentially I'm taking out from the equation the entire execution of the service, pretending that I know the object has to be supplied as a parameter, and I know the value which is returned back from the object itself. So this is a very simple change, which might seem redundant to you, but it will drastically simplify the use of expectation inside and mock inside our test. So we can simplify tests by being able to isolate dependencies. We will improve our unit testing because we can actually test our controller. We are not testing the processing or the order. We are just testing that our order controller, given a certain input, will render back the output in a specific way. We don't care how the output is processed because it's not the expectation of this specific test to test the processing of the order. And this is another really big topic. I feel that every time I talk about dependency injection in the Ruby community, it's like, wow, what's that? And that's a big influence that I got, for example, from Go. In Go, you use dependency injection a lot because there's no easy way for testing. And in fact, there's no, for mocking. And there's no even easy way for mocking and stubbing for a specific reason, because you can really easily abuse that. So this is an example of a coffee machine. I want to focus on a specific section here, the dependency to the machine service, which is a third-party service, an external service that I'm going to contact. This is really hard to test, again, because we have to set an expectation of the whole coffee machine service and use the expect any instance of, which is really, really bad design. And so let's try to improve and take out the expect any instance of. And that's going to be even worse because we have to set a mock on a class to return a double, then we mock with an expectation. Okay. So how can we change that? We actually have even a more complex example. In order to test the retry, that's the code I have to write. I have to mock the machine, pretend that the machine will return an error the first time, and then we'll receive another method. We change the state of the machine, and then this time we'll pass and we'll succeed. So let's try to refactor the code. Let's focus on the dependency. What we can do is that we can inject the dependency during the creation of this specific class. So the responsibility of determining how the coffee machine is implemented is going to be outside the scope of this library. That's called dependency injection. And what we do here is that we just pretend to have a machine object that was set up somewhere. We don't care about that. We don't really care how the machine works. And the beauty of that is that we will be able to simplify our code by taking out that specific. Oh, no, that was not supposed to jump from there. But taking out that specific dependency and, yeah, sorry, I skipped a slide. And by passing the coffee machine in the subject here as a separate object from the outside. And the coffee machine, as you can see here, is a completely different object, and at that point, I can completely get rid of this line, right? And of course, I will still have to have some expectation of the machine itself, and there's one way to move forward. I can actually create a completely different test object, something that is often called a no-op object. I don't care how the object will perform. It's a test object. I just expect that the machine will somehow be able to respond to a certain method. How it will do that, I don't care. I'm not testing that. And so that will greatly improve how we use all the tests that somehow are going to invoke this object. Because I don't care about stubbing at the coffee machine, because somewhere a customer was pushing the button, and so I have my customer class that is going to call the coffee machine, which will prepare the coffee and so on. I don't care about that. And I just care that somehow along the chain, my objects are properly behaving in the way that I'm expecting them to behave. And this is our final coffee machine, no dependencies. It's actually fair to say that this is not pure dependency injection, because I still have some knowledge of how the coffee machine is designed inside my class. So this is not pure dependency injection, but the point is that we are not here to blame and to pretend to be academic on the code we write. Any improvement with what we wrote before is way better than what we had before. So small improvements are better than no improvements at all. If we want to be academic, then we can decide to make that machine dependency as a mandatory object, and we pass that. But we can also use another approach. We can use the approach of the default values. We can use a registry pattern and delegate the machine creation somewhere else. And we just have a dependency to the registry, which is in this case is absolutely fine. We have examples in the wild pretty much anywhere. This is an example in the Go standard library where the output functions, like, for example, the puts function in Ruby, are actually designed with dependency injection, where the receiver of the output is injected as a dependency injection. So we have like a convenience method, but as you can see here, the print is defined to take a stream, and the fprint just design how the printing of the data is encoded. So how my code changed today, we inject database connection, for example, like Redis dependencies. We inject services dependencies into other services to keep services isolated from other environments. We inject environment-based adapters or strategies. Think about test adapters that don't connect to real services when you're running the test, or staging adapters that don't perform the creation of resources, for example, on, I don't know, send email or something like that. And then we inject no-op test adapters to replace external services in our test. The result, improve the coupling between resources, simplify tests by reducing setup, and increase test effectiveness. I quickly want to go through another example, powerful error handling. I actually don't think I have a lot of time, but I want to quickly go through that. We have this code here, and this code is rescuing from a specific error as part of a library. Now, you have to think that this code is in the context of a very, very complex service that has a very deep chain of calls. Now, this is pretty inspired by how Java works. Yes, you can be inspired by Java. And what I want to show you is that this is the typical example of the code that we have. We have a base error object that inherits from standard object, and we have another, like, more specific error. Now, what's the problem here? The problem is that we have at least one case, the argument error, where our library is raising an error outside the package itself. So there's no way for me to rescue all the errors that that specific library may raise. And that's going to be a problem, because in a chain of calls, I may have an argument error which is raised in somewhere and will be really, really hard to be catched. So what I can do, and I can take advantage of the fact that in Ruby, you can use modules as a rescue statement. So I can use a module to tag my errors. I can change the error to be a module, and I will create a specific error class where I include the error. And what's the beauty of that? The beauty of that is that I can now create an argument error which behaves like an argument error, like a global argument error, but it's actually also tagged as a specific error. And my original code doesn't even have to be changed as long as I am inside the scope of this library. Or I can make it scoped, but it doesn't have to be. And even this code doesn't have to be changed. By rescuing from Let's Encrypt error, I will rescue all the exceptions that my package is going to raise. Again, I can also have different kind of rescue statement, like specific statement for like inner errors and for all the errors. So I can specialize my rescue statements even more. There's also another really interesting use case of exception that, again, is taken from Java. Unfortunately, there's very little documentation about that. It's called coast. We don't have time, so I'm going to go through that really quickly. But what will happen is that you can have exception rescued and re-raised as a different kind of exception where you keep the reference to the original exception. Why is this useful? As you can see here, I can rescue a generic timeout error, repackage that as a custom error. And what will happen is that when my error will be rescued, I have either my error, but I can also know whether the error was triggered by something else. Okay. And there's also here an influence from Go. I want to point you out how in Go, it's a standard practice to use lowercase error messages. Why that? Because exceptions are supposed to be chained together. Errors can trigger other errors and so on. The more you go closer to the user, the more the message will be user-oriented. But if you don't have this kind of approach, you will have mixed cases, and the final explanation will seem really weird to the user. It's a very small, trivial example, but it gives you an idea of how Go is really focused on readability. And again, you wouldn't expect that from a language that has a lot of similarities to C. So my code today provides error modules to tag exceptions from specific packages and provide the default package exception. I use the word package because to me has a meaning, even in Ruby where we don't have packages. And then we subclass package error when needed, so when we have to provide a more specialized rescue statement. And that will facilitate error handling by wrapping all the exception, repackage the exception, still giving access to the original error. I have a challenge for you. What would you do if Ruby would drop default parameters tomorrow? So imagine a world where you cannot write this code. You cannot write the code where you have default values. So Go has that. Go has no default parameter values. And that changed my mind of how I design my code. I have to think about my code before writing it, because I won't be able to change that so easily. And that's an example of how you can perform the same thing in Go by using, for example, a configuration object. So as you can see here, I have a method that wants different kind of default parameters. And what I do is that I create an object, a struct, a data that encapsulate the logic of the parameters that can be configurable. And I can even compose them. So the list option is actually base list options, and for domain, I can have extra configurations. And that makes a lot of clear what are the options that my method is taking. So no options equal hash, which you have no idea which options are going to be taken by that specific method. And this is how you use it in Go. You pass nil when you don't need configurations, or you pass the specific object instance. Again, is it more code? Yes. Is there a problem? I'm a developer. I don't mind writing code. And in fact, we have to appreciate the value of the simplicity. And this is a mind-blowing talk. I want you to take note and come back home and look one of the next days. My slides will be available online. This is an amazing talk from one of the creators of Go. Simplicity is complicated. It's an amazing talk. And some of the quotes are preferable to have just one way, or at least fewer ways, to do one thing. Features add complexity. We want simplicity. Features hurts readability. We want readability. Readability is paramount. So how that was applying to my code? No alias. And I have actually a story about this specific use of alias, but I don't have time. I will be happy to disclose that. Single, clear API. Just provide one way of doing it if you don't need them, right? Look at how easy is this code to read. I only have one way of doing it everywhere in a single place, all of that in a single place. Again, simplicity and verbosity. Being simpler doesn't mean writing less code. Doesn't mean not being verbose. And in fact, sometimes I have to be verbose. Now look at here. I take a domain name, which is a string. I pass that to a domain object. And then I pass the domain object as an argument to the check domain that will extract the name from the domain. So we return back the string. That's verbose. But if I design that the check domain always have to deal with the domain object, why should I mix that sometimes to deal with the string and other times to deal with domain objects? That will make it really complicated and really hard to maintain my code. And in fact, that's a refactoring that we made as a result of a bug. The domain object was making some transformation that by passing the string, we were missing, and so we introduced a bug. This is an example of another simplicity enforced by conventions. And this is a tool, Rubocop, that has been mentioned, which is something really close to Go format that will apply sort of common convention to your language. I'm going to wrap up everything by getting back to the roots of this talk. So I've mentioned about 3 different languages. I mentioned about Elixir. And so I've shown you how Elixir changed my way of writing Ruby code by using more functional approach into the Ruby language. And as you would say today, Ruby is not a pure functional language. And probably trying to make it a pure functional language would be a huge mistake. We don't have to pretend to have Ruby as a pure functional language, because pure functional languages have different constructs. For example, you don't have for each loop. You have to use recursion in order to loop over a list. And Ruby is not optimized for that. But that doesn't mean that we cannot use some of the key concepts, like reducing the side effect of a functional language like Elixir, to write and improve our Ruby code. Then we have seen how Go changed my way of approaching writing Ruby code. I don't feel bad about writing a 15-line of code, 15-line of Ruby method. I don't feel bad about using design pattern like dependency objection. And in fact, all of them were used in less complicated code and easier to test code. And finally, I haven't talked a lot about Crystal, so you may be wondering, what are your influences? What Crystal changed the way you're coding. So the way Crystal changed the way I am coding. So first of all, I have to admit I haven't written a lot of production Crystal code. In fact, I haven't written any production code at all in Crystal. Most of the code I wrote were experimentation on my own. But the beauty of Crystal, the way that Crystal changed my mind, is that I can still keep enjoying Ruby. I can still use Ruby, and Crystal brings me what I love from Ruby and introduce some features that large projects may benefit from, like static typing, like compilation, like code generation, in a way which is not provided by Ruby, and I can see that, I can find that in other programming languages. So that made me keep appreciating what we have today and the features that we have, and what made me choose programming in Ruby and what kept me programming Ruby these days. And thank you very much. I hope you're still alive. If you have any questions or even objections, I will be happy to answer. Yes, so it's a very bad practice because you have very little visibility of what's happening. When you say any instance of, now imagine you are testing a code which is dealing with a model. Like you have an account model and you are testing some code that deal with the account model. And you say any instance of account. It can be anything. You can possibly be testing anything. And the fact that you have no easy way to access the specific instance of the account you're testing or working with is an example of the fact that you have very tight coupling with the code that you are writing and dependencies, because you have no way to swap that dependency. And think about that in the real world, when potentially you will have to change a dependency, introduce, I don't know, a different service, a different object, a different model, or refactor the code. That dependency, that really strong dependency will make it's a sign that will be really hard to change your code in the future. So not being able to access the object you're pretending to test, it's a bad sign of something that you have to address. Plus, it's really hard to write code with any instance of, especially in RSpec, because when you have to set different expectation, so the same object is receiving during a single call different messages, so different method calls. You have no way to say which one is going to be called before and the order of them. And you have no even way to say that, I don't know, the same object is going to receive those methods. It could be like the object A is received one of them and the object B is received other of them. So your final test will be just like wild guesses. I hope I answered. So the question was essentially specific on the section about structs, and was whether in DM Simple we use any specific library to somehow like simplify the way we write struct code and deal with like common tasks like manipulation and sanitization of the data. So we don't use struct at all. So we don't use the standard library struct because it didn't work very well for us. And what we did is that we have a simple, super simple library that essentially is just a hash-like object that simplify the way we can set up a list of attributes and get them and set them from the outside. In the struct, we don't perform any type coercion or validation, specifically not at the struct level. For us, the struct are just container of the data. Libraries using the struct are responsible for making those kind of changes, or if we have specific need, so for example, we have an object that we created, which is called the param object, that represent what you're used to see as a hash, or now as a param inside, for example, race, which is essentially, I would say, hash on steroid. We have that kind of object that at the very base level is a struct object, but has some extra abilities about validation. And in that case, we just start from our base object. And on top of that, we add whatever requirements we need to perform the validation and sanitization of the attributes. And the reason also we try to limit the dependencies is because sometimes we started using structs mostly for libraries that we could take out from our code, like for example HTTP clients, like the client that connects to the service we use for sending emails, for example. And that code eventually became a separate private gem. And using libraries or depending on other objects that were somehow part of the bigger environment of our application would have made that really hard to be taken out lately. Right? So we have a very super simple module that it's no more than 50 lines of code that simply provides a quick accessor for setting and getting data. And we build other objects on top of that depending on the needs. Okay, cool. I think we are done. Thank you very much for being here.